Are you there?
Yes, I'm back.
Let me know when you are done with question number 21. This is, wait a minute. For question number 22, there is an fourth option that is below that. Very good. Go for the question number next. Predict the product and the reaction. These are the options.
Can you show the question?
Yeah, this is the question. Just wait a minute. Let me. Can you see the question now completely?
Yes, sir.
Very good. Shahid.
Yes.
It was already. Very good, Arif. Both are correct. Shahid, will you be able to do it? See, very simple it is. The order of stability of the following tautomeric compounds. As you can see, double bond is in between. There is, what do we say? Symmetry. So third will be the most stable. Then comes your second, and then comes your first. So symmetry, due to symmetry, this will be the scenario. A will be the most stable. A option. Predict the product in the reaction. So first you need to recognize that this is a Cannizzaro reaction when there is no alpha hydrogen and you are going to react with 50% KOH. And in Cannizzaro reaction, what happens? Disproportionation reaction takes place. Disproportionation reaction takes place. That means this compound will be oxidized and this compound will be reduced as well. So you know that when aldehyde is going to oxidize, it forms carboxylate anion. So here is your carboxylate anion and it will also basically, what do you say? No, not, wait a minute. This CHO will be oxidized into carboxylic acid salt. So this is not oxidized, basically it added one more carbon, that's why it is wrong. Come to this is your OH, it is reduced, this is also reduced, so basically it will also not be the correct answer. But if you are going for this aldehyde is oxidizes into carboxylate anion and this aldehyde is reduced into alcohol. So the correct answer is C. This will not be replaced, this will be as it is. Shahid, did you get this? Very good. Okay, I'll explain it. Wait a minute. Fadil, did you just join?
Yes, sir.
Okay, here is the possibility. See, stability of this. First, whenever you are going to do the stability, you are going to find out the symmetry. Symmetry, if you are going to see, there is symmetry, there is symmetry. Out of these two, which one is more stable? This one is more stable because of hydrogen bonding. OH is there and hydrogen will be there, so it makes a hydrogen bonding. So that's why third will be the most stable. Then symmetry is there, so it will be most stable, and then comes the first. So third is the most, then second, then the first one. Is that clear, Shahid? Okay. I'm gonna change the slide. Very easy it is. Any answer? Shahid, it's a wrong answer. See, I'm going to write, explain it. CH3CHO, that is aldehyde, and this is also aldehyde, can be distinguished chemically. Benedict test, yes. Tolerance test, yes. Fehling test. These are all, this will be basically oxidized into carboxylate anion. But when it comes to iodoform test, there must be methyl group. Like this is connected with CH3, but this C6H5 here, this CHO is not connected with CH3. That's why it will not react with iodoform test, and hence this is this test will distinguish between the ethanol and then this benzyl ethanol. Is that clear? Very simple it is. So iodoform test not given by this C6H5CH2CHO, but given by CH3CHO. Do you have any doubt in this? Shahid, Tharif, and Fadil.
Yes, sir.
Shahid, very good. The 25th question that you have done is correct. Tharif, what about you? A is correct. Basically, in question number 26, two options are correct. 25, two options are correct. So in 25, if you are going to check, no, wait a minute. Wait a minute, please. In 25, option D is the correct answer. Now, what is the question? Consider the reaction this. What sort of reaction it is? So it is electrophilic substitution or elimination reaction. I can show you this reaction. This is your RCH double bond O and going to react with H2N. NH2 NH2 hydrogen. So H2N, I'm going to write it like this, and H2N, NH2. So what will happen? Very simple. You are going to eliminate this water molecule. So if you are going to eliminate this, this will be RCH double bond and NH2. So substitution elimination reaction this is. For 26, It is A and D, both option. For 26, which of the following compounds will give a yellow precipitate, that is acetophenol, as well as 2-hydroxypropane? Very good, Arif. 27 is the correct answer. Very good, Shahid. Fadil, you are not able to answer it. Is there any problem with the concept? Fadil is not here. Okay. So see, in the 27, question number 27, Clemmensen reduction of a ketone is carried out in the presence of which of the following? Zinc, amalgam, and HCl. Very simple it is. Moving to the next part. This. Any answer? Very easy question it is. Very good, Tharif. That's a correct answer.
The options for the 29th question.
29 is also yes. Sahid, say order of reactivity of phenyl magnesium bromide with the following compounds. So when PHMGVR will going to react, there is very less bulky group. This is a too bulky group and too much bulky group is here. So the best to attack is this aldehyde, then ketone, and this is also ketone. So the answer will be 1, 2, 3. Reactivity will be more in aldehyde than 2 ketone. One with methyl bulky group and another is phenyl phenyl very large group. And 29 is, you can see following compounds are given. No, wait a minute, I didn't give the option. Just wait a minute. Following compounds are given. Which of the following option I didn't give? Here is the complete question for 29. See. Which of the following compounds on being warmed with iodine solution and NaOH will give iodoform test? Any answer for this one? Following compounds are given this. Which of the are basically iodoform test it is given. So which one will give? So I told you all are alcohol. Where you can see this is your CH3CH2OH. So this is your functional group. So to this, if CH3 is attached, methyl group, it will show. For the second one, ketone is also there. So this is your functional group. If methyl ketone is this will also show. The last third option, you can see this is your functional group to which carbon is connected. Methyl is there, it will also show. So the next one is methanol. This is your functional group. After this carbon is not attached with anything or any methyl. That's why only 1, 2, 3 will show this test, iodoform test. So 29 is your D. Is that clear, Sahid? Okay, go for 30. Question number 30. Which one of the following compounds will be most readily hydrated? Hydrated, that means dehydrated, that means you are going to remove water, that means formation of double bond will take place. So search for most acidic hydrogen, and alpha hydrogen is most acidic hydrogen. Any answer for the 30th question? Arif, Shahid.
On
What did you say, Tharif? So basically here what you are going to do, the most acidic hydrogen, alpha hydrogen is the most acidic and here is your alpha hydrogen. So this will be the most dehydrated, easily dehydrated. Very good, Tharif. Is that clear? Can I change the slide, Shahid? Okay, please do this. This is you need to react acetophenone with this. When reacted with the base, it will react with the base. This to yields a stable compound which has the structure. Do you know the structure of acetophenone? Will you be able to do that question number 31? Yes or no?
Yes, sir.
Okay, I'm going to explain this. So very simple it is. Let's say this is your pH. That means benzene group C double bond O CH3. Uh, Wait a minute. Yes. And another I'm gonna take this CH3 is there, CH2 I'm going to take, and hydrogen is there, and then C double bond O, and then pH. In the presence of base, that means OH minus. What you need to do, very simple it is, pH, and then C double bond O. One will be reduced, COH, and then here it is CH3, and then comes your CH2, and then C double bond O, pH. After this, H plus or heat in the presence of water. So you will be getting pH, that means this benzene, C double bond, CH3, then comes your CH, C double bond, O, pH. So according to this, you can see that this reaction is basically your aldol. So the correct option you can see is this one. So the correct answer is A. Is that clear? Very simple it is. Aldol condensation is there. Let me know when you are done with this. Question number 32. Very good, Harif. Shahid, what about you? A strong base can abstract an alpha hydrogen from. Yes, it is. Very good. Oh, yes, Shahid. Let me show you. This is the question. Let me know when you're done with this. Very good. Now start doing this question. Very good, Shahid. Go for the next. After 33, what is the answer? Very simple it is. Very good, Tharif. Shahid, see for question number 34, 50% aqueous sodium hydroxide. That means basically it is Cannizzaro reaction. And in Cannizzaro reaction, what happens? There should be no alpha hydrogen. There is alpha hydrogen, there is alpha hydrogen, there is alpha hydrogen, so this will be left. Is that clear, Shahid? Very good, Tharif. For question number 35, it is also very easy. The product formed in aldol condensation is beta hydroxyaldehyde or beta hydroxy ketone. Aldol condensation. You will get it. Is that clear? Any answer for question number 36? Very good, Tharif. What about you, Shahid? Oh, 37, it's wrong, Shahid. And you are correct, Tharif. So see, very simple it is. 36. For 36, it is C. Why it is C? So when you are going to do the hydrolysis, positive charge will be creating on this. So it will withdraw. And the one which is having more electron withdrawing group will be the, just wait a minute, I did a mistake. NO2 is there. NO2, C6H5Cl, CH3OHC. So this is having the most withdrawing power. So this will be the first. And then comes your after this, which one is most withdrawing power? Aldehyde. So C is the correct answer. This, then comes your first, because this has releasing group. This is withdrawing group. This is also withdrawing group. This is releasing group, and there is no releasing group. That's why it comes before this. So this is number one. This is number two. This is number three. This is number four. So option C is the correct answer. And fair, and 37, you can see on 37 acetaldehyde you will get. If you are going to react this CH3C double OH with HCN, what you will get? You're going to release this and you will get basically CH3C. Very simple it is. Nucleophilic addition reaction. It will be like this. And there is negative, there is positive, there is negative, there is positive. So this positive will go here. So it becomes OH, and here it comes out to be CN. After this, you are going to do the hydrolysis. In hydrolysis, what will happen? CH3 is there, C, and then OH is there, and then hydrogen will be there, and this CN will be converted into carboxylic acid. So the answer will be, wait a minute. So you can see a carbonyl compound reacts with hydrogen cyanide to form cyanohydrin, which on hydrolysis forms a racemic mixture of alpha hydroxy acid. So this is your alpha hydroxy acid, and the carbonyl compound is acetaldehyde. You can say this. Is that clear? Is that clear?